A very good day to all the viewers that watches this video. This video is about the Q&A session following my FYP presentation. In this video, I will be answering two questions. The first question that I will be answering sounds like this. If I were able to conduct the experiment and compare the performance of bare copper and thin copper for the same cross-sectional area, what would I anticipate? So before I further elaborate on this question, I would like to explain more about the characteristic of copper first. Generally speaking, copper is one of the few metals that exist as an element in its natural form, and this is because copper is almost totally resistant to corrosion. But this statement does not mean that copper will not corrode, and as a matter of fact, the rate of corrosion of copper increases exponentially when it is subjected to humid and high temperature environment. And thinning of copper is an effective way to strengthen the properties of copper, hence making it more resistant to humidity and high temperature. So according to Distributor Wire and Cable Company, the operation of bare copper should be kept under 100 degrees Celsius to prevent oxidation. Furthermore, in accordance to a report entitled "The Effects of Temperature and Velocity on the Degradation of Copper Pipes in Recirculating Hot Water System," done by a proprietary company of the name Nicholas Corrosion, they inferred that common practice for the application of copper pipe should be below 60 degrees Celsius to prevent oxidation. However, this inference had included the consideration of water velocity flowing in the pipe. On another note, according to Annixter Incorporation, the thin copper can effectively prevent oxidation up to 150 degrees Celsius. So, from all these affirmations, we can deduce that operating temperature of bare copper cables and thin copper cables should be kept under 100 degrees Celsius and 150 degrees Celsius respectively. Other than that, the solar cables are designed to be UV resistant, weather resistant, and also resistant toward acids and alkali, according to the standard EN 54618. Therefore, we can conclude that humidity is not a variable that can determine the rate of deterioration for cable conductors. And apart from that, according to Annixter Incorporation again, the conductivity of tin is only 15% that of copper. Hence, the thickness of tin deposited on copper cables will affect the overall current carrying capacity of the respective cable. All in all, I can conclude that bare copper solar cable can perform better than thin copper solar cable when the ambient temperature is below 100 degrees Celsius. And to put this in perspective, the highest average monthly temperature Malaysia experienced between 1825 and 2015 is 28.26 degrees Celsius, according to this website. And in this context, bare copper solar cable can perform better than thin copper solar cable. As for the justification of my second question, I will be explaining on the difference of performance for cables with different cross-sectional area. So do I think that a 6mm squared cable can perform the same as a 60mm squared cable? The answer is no. This is because the difference in cross-sectional area also equates to the difference in conductor resistance and also the current carrying capacity of the cable. However, if the cables are single-stranded, the eddy's current will be higher for cable samples with larger cross-sectional area as compared to cable samples with smaller cross-sectional area. And the magnitudes of eddy current is also directly proportional to the losses. Hence, to reduce the aforementioned difference in performance of cables with different cross-sectional area, IEC 60228 had set up a standard for the required number of strands and diameter of strands for insulated cables with different cross-sectional area as shown here. And that is all from me. Thank you.